meeting. So looks like the difference, if you include the endpoint or do not include, is in the way we have the bracket. So if I want to take that point A and include it, so I fill that circle. Or if I don't include, like in the first example here, I have parentheses. So that's a very popular way to show if point is in or out. I'm talking about ends, the end points for the interval. Well, let me take a look at the exercises. We've done some of those at the end of the previous class meeting. So we were comparing various numbers, and we also were writing down those intervals. So let's say if I try problem number 99, that looks kind of different. It says x is less than or equal to number 7. But instead of just writing that x is less than or equal to number 7, for some reason they put this braces on the top, or actually around that statement, and then the bar after x, and then put x less than or equal to number 7. Well, this is so-called notation. So sometimes you'll see, instead of just statement that x is less than or equal to 7, this type of expression. Well, all you have to do is pay attention to what happens here after that bar. That's actually what we're looking at. And now I can put number 7 on my number line, included, right? So I can fill the circle to show that 7 is included because x can be equal to 7. So that's why we have that equal sign, and the circle that I filled corresponds to that 7 with equal sign. And then since x is smaller, well, then we consider all x's way to the left going infinitely. So in other words, this interval could be treated as negative infinity all the way to 7. And we put 7 with a bracket to show that it is included. So what I just did, I wrote the same thing basically 3 times. So the same exact expression I wrote with inequality, made a picture on number line, and used interval. So those 3 ways to write down the answer are the same. Well, but you should be aware of this. That's the point. I say, so how do I write down the answer? Any of these 3 ways, because I will understand that you produce the answer. Well, in this group of exercises, they just say graph, make a picture. So they just cared about the second way to write this. And actually, that's what you see here underneath as the answer. So I would say that's a kind of formality, So we looked at this inequalities, and then we also considered a second section of this chapter that worked with adding, multiplying, subtracting, and dividing various numbers and fractions with plus signs, minus signs. So I just care, as usual, about the so-called guided practice exercises that are in the middle of page. And, well, I just select a few problems and do them. That's what we actually did last time. And I think what's very helpful is having answers right next to the exercises, right? So we So the rule, when we multiply, two minuses give you a plus. Let's say if you consider exercise 49, then -9 times -3, 9 times 3 was 27, and the sign was positive. So when you multiply or divide, two minuses give you a plus. So like in problem 57, you divide two negatives and the result is positive. So 49 divided by 7 is 7, right? So it's convenient to see the answer next to the exercise. So two minuses give you a plus when you multiply and divide. But when you add or subtract, things change. For example, if you look at exercise 31, when you add two negative numbers, well, the result is still with a minus sign, because when you add numbers with the same signs, what you do is you keep that same sign. So when you multiply, it's different rule compared to addition or subtraction. So I guess that's what's important to realize. You can always use calculator to double check if you produced correct sign, but I guess one needs to be aware that it's not the same. Again, this is a review of arithmetic, so I hope that you already saw this before. So I just want to take a brief look at this, and what if I do another exercise here? When you, let's say, try to multiply numbers, like from this group of exercises that says evaluate or calculate, in other words. So if I try to multiply three numbers now for a change, like in a problem number 110, you're multiplying three negative numbers. So when you multiply three negatives, then the result will be negative, because here I multiply -5 by -12 and by -3. So first of all, one can say, Alex, who told you that they're supposed to be multiplied? I don't see a multiplication sign in between. Well, it turns out if you don't see the sign in between, it means it's multiplication. So that's how people treat this. So if I have to multiply, I can start on the left and go to the right. So the product of the first two will be a positive, because two minuses give you a plus, right? So it'll be positive number 60. 5 times 12 is 60. And then I have to take -3 and times it by 60. Notice that -3 is in the parentheses, which means they actually multiplying these. And now our result will be with a minus sign, because we have only one negative here. And I multiply number 60 by 3, and that gives me 180. 6 times 3 is 18. So yes, the calculator could be used and it should give you the same exact result, but I don't think it's very hard to do this by hand. So the key idea is two minuses give you a plus, and that you multiply from left to right. That's how people usually go about this. So I'd like to take a look at next section that talks about exponents, and the exponents utilized for convenience. What does that mean? Well, it happens when you multiply three exact same numbers, like in the page here was 5, then you can treat this as if you take 1/3 and raise it to the power of 3. 1/3 cubed. So if you multiply exact same numbers again and again and again, well, you can write this shorter. So you don't have to write 1/3 3 times. You could just put a third, but raised to the power of 3. So just to make things a little bit easier and shorter. Like in the problem in example 4 here, instead of taking -3 and multiplying it with itself 4 times, you could just raise it to the power of 4, get -3 to the power of 4, just like that. So it's much shorter, and I guess that's much simpler to produce for the answer. So that's pretty much all we need to know about the exponents. So they just designed to help you simplify things. And here in the section, they put lots of so-called properties of those exponents. So for example, here we have 3 squared, which is cubed. So what you have is multiplying, let me write it here, 3 squared, which is raised to the power of 3. What you do is you multiply those powers, 2 times 3, and you get the 6th power. You say, how come I'm multiplying these powers? Well, you can actually see this if you had your 3 squared multiplied with another 3 squared and multiplied it with another 3 squared. You see that instead of using this power of 3 on the outside, you can have 3 of these factors, 3 squared, multiplied with each other. I say, so why power is 6 at the end? Well, because instead of every 3 squared, you can have 3 times 3. That's the first one. And then next will be again 3 times 3. And then again will be 3 times 3. You say, Alex, what are you doing? We already have the answer. Well, I'm just trying to show you that formula actually makes sense. So there are 3 products here, right? 1, 2nd, and a 3rd, but actually the 3 is multiplied with itself 3 times. 3 of 3 pairs. So it's actually 6 times. And that's why they wrote it 3 to the power of 6. But of course, it is a little bit tedious to write it all down. It's much shorter just to put product of these powers, 2 and 3, and you get 6 right away. Well, you say, so what is 3 to the power of 6 actually? Well, you could use a calculator and see that it's 729. Remember, I shown you this free calculator that I found online. Just type in scientific calculator. See, when I start typing, it already appears in the choices, scientific calculator. And I was taking the Desmos, right? This is online calculator. So you can just take the 3 and raise it to the power of 3. Question is, how can I do this? Well, there is a special symbol that we utilize for the powers. It's right here. So when you entered your number 3 here, so just put 3, and then I click on that symbol for the powers, and that allows me to enter the power, which is 6, and you can see that it is ended 729, but you could just leave your answer as 3 to the power of 6 also, because we usually don't calculate powers that are bigger than 3. So it's power of 6 is just a big power here. So this is the way we deal with those exponents. So let me try to do some exercises in this section. So let me go to the end of the section just to refresh your memories on how we simplify those various expressions. So as usual, I don't want to look at the first group, which is called warm-ups, and then vocabulary or review. I want to just look at the exercises that are called here in the section practice, right? So here's the practice exercises. So let me just, oops, I think I misclicked something here. Let me get this. Okay. So let me clean this a little bit first. Nice and clean. So let me do a couple of problems on this page just to make sure that you feel okay about the exponents. So how about if I take problem number 51 that says, so I'm in the section 3 of chapter 1, so that's a new little section. And exercise 51, that's where this guided practice story starts. That's where you can do the homework from. So -3 is being in the parentheses squared, which actually stands for a -3 multiplied with another -3. So for convenience, whenever we have negative number raised to some power, we put it in the parentheses. So it's going to be +9, as you can see here, because we are multiplying two negatives and the result is positive. On the contrary, on the exercise above, an exercise number 49, we actually have a -3, but without parentheses squared. What does this mean? Well, this means that minus has nothing to do with the power of 2. So that minus is not being squared because there is no parentheses. That's the difference with exercise above. So all you square is just 3. So that minus is going to stay, and when you multiply 3 and 3, it's 9, but the negative sign is still present. See the difference? When we have parentheses and we don't have parentheses. So when we have parentheses, the result is positive. When we don't have parentheses, the minus will stay, the result is always going to be negative. So that's something that is important to realize. So let us try another problem here, like exercise number 55. In the problem number 55, I have 2 powers of x to multiply. I have x power of 3 multiplied by x to the power of 5. So what happens here is I have 3 factors of x in my first piece, and in the second piece I have 5 x's because it's power of 5. So the question is, how many factors of x I have here? Well, we'll say that's a power of 8, right? Because there are 8 many of those. So the power is 8 in this case. So it looks like we actually add in powers in this particular exercise, and that's a property of those so-called exponents of those powers, that you actually take 3 and 5 and add them together. So the powers will be 3 plus 5. That actually equals to 8. So you can utilize this idea in exercise number 56. So y then will be raised to the power of 6 and 4, right? That we add together here. And 6 plus 4 gives us exactly that 10th power of whatever letter we have. Y or X doesn't really matter. So we add the powers, and that's why people sometimes say that you need to add powers in general when you multiply in the same exact exponents. So let me get some room here and write down this interesting formula that tells me to add the powers. So when I have x raised to the power of, say, n multiplied by x raised to the power of m, then what I have to do is add n with m. So I have the power of x, which is a sum of these exponents. Please notice that's exactly what I did in previous exercises. So other part of the story that happens when you divide powers instead of multiplying, when you divide. So when you divide the powers of x, then you're gonna subtract these exponents. And we can see this by looking at the example here. So for instance, if I try something like problem number 95, let me do 95 here, where they divide the powers. So if I have here a raised to the power of 8 is divided by a raised to the power of 3. So we divide, it means we need to subtract those powers. 8 and 3 will be minus one from another. And that's how we get a raised to the power of 5. A to the power of 5. Let's see, really? Let us check this out. Well, the power of 8 means that you actually multiplying 8 letters A. That's not very convenient to write down, right? It's annoying. But here they are, 8 of those factors that I divide by a raised to the power of 3. So there'll be 3 a's in denominator multiplied. So I can cancel this 3 a's with another 3 a's on the top, and notice that what's left will be 5 of those letters A. So instead of doing all that, the formula tells me just subtract those 3 a's on the bottom from whatever we have here on the top. So just subtract them and get the answer. So that's what this second formula actually talks about. Well, this second formula will actually help us to see what is 0 power equals, such as in problem number 79. Notice that in that exercise, we raise number 8 to the power of 0. And one can say, how come the power could be 0? Well, we can justify this by actually looking at the formula that we just considered. So let me try to divide, let's say, x to the power of 3 by x to the power of 3. And you say, you can cancel these, right? But on the other hand, using the formula that we just saw, we need to subtract those powers of 3. So from the one on the top, I subtract the one on the bottom, and that's actually nothing else but x raised to the power of 0. Because 3 minus 3 is 0. Well, on the other hand, when you divide the same number by the same number, you always get 1. Let's say if you divide 5 by 5, isn't that 1? Right? Or if you divide 10 by 10 or 11 by 11, so if you divide in the same exact numbers, you always get 1. And this is also true when you divide the same exact expressions. So people say you can cancel these, and the result will be equal to 1. And that actually tells us one very interesting fact, that 0 power is the same as 1. That's what we just produced. Looks like, look at this. X to the power of 0 on one side is equal to number 1 on the other side. Which is quite amazing, right? When you say the 0 power, what does this really mean? Well, it means it's 1, and that's all it is. So an exercise like number 79, 0 power of 8 is equal to 1. When you say, what about problem number 80? Why the result is negative? Well, because remember, we already saw this idea before. If you have a minus sign, it has nothing to do with your power, so the minus sign will always stay if it's not inside the parentheses. And that's important to realize. So problem like exercise number 84 will have a minus sign with a 3 that stays and has nothing to do with parentheses. Let me try to write it down here. So number 84 has a negative 3 multiplied by x raised to the power of 0. Well, we just saw what x to the power of 0 equals, right? It is 1. No matter what x is, it's always going to be equal to 1. So when you're multiplying number negative 3 by 1, well, it's still the same negative 3, because if you multiply by 1, nothing changes. So the answer is minus 3. Just like that. I'm kind of wondering that we have 16 people right now logged into the Zoom. So I believe that there are more people registered for this class. So I think it should be another 10 more students. So where are they? I hope they didn't get lost. And I'm just wondering, is anyone in the classroom right now? Because I'm not in the classroom. I'm out of campus, but I will be back in the classroom next week, or just in case. So just wondering if anybody's in the classroom. Just let me know if you're in the classroom, because I'm just wondering where the other people that registered for this class are. Are they just in the classroom, or they just forgot it's too early and they still sleeping? So nobody here is in the classroom? Nobody is on campus today? It looks like all of you are in your place somewhere, which is good, so you don't have to go that early to school, right? So you can enjoy it from your place, but it looks like you're all not on campus. Okay. So if somebody is on campus, I will just please let me know. Oh, there are a couple of people. So you guys in the classroom or someplace else? Because I just worry if someone is in the classroom and, oh, okay, that's very good. So actually, looks like the rest of class, because again, I see that 17 people are logged in, including me. So there are just 16 students, right? And on the list, I saw I have like 26 or 27 registered. That's why I'm wondering where the rest of class is. Well, what I can do today is I'll give you a little quiz on what we are doing, so I know that who is here. So instead of collecting attendance, remember I told that I usually give a little quizzes, and that's how we can go about it. So let me do the problem for you before the quiz. So I will have a very similar exercise for you in the quiz. So I'm looking at exercise 81 or 82 right now. Let me do problem number 82. So in exercise number 82 here, we raise into the power of 0 something in the parentheses. So inside the parentheses, we have minus 3a7b, but the result is 1, simply because the formula that we just considered here in the upper left corner tells that no matter what is raised to the power of 0, the result is 1. So let me give you a little quiz exercise. What I'm going to do is create my own one, similar to this one, to number 82, for a little quiz for today. So what you should do is give me the answer in a Zoom, and please don't hurry. Put the answer in the chat. So in the Zoom chat, you should put the answer to this exercise. So what is a 0 power of 5x squared? But please send this answer only to me, only to Alex. Don't send this to the whole class, because if you produce the wrong answer, people are not going to be very happy. So please don't forget to put this answer in the chat. And then after, you can log out from this class, because at the end of class, I give a quiz. I'll give you some more than 10 minutes, so don't hurry. Take your time and just give me the answer here in the chat, and then you can log out and enjoy the day. So we're gonna have the class over after you put the answer for the quiz. I'm gonna stop to record.